so today we're actually going to be doing some official work in the book with 10.3 and 10.4. So we've been doing a lot of like sideline stuff with unit circle going forwards and then also going backwards. You should have at this point be relatively good-ish with some of the unit circle things. So we're just going to talk about very specifics that are in the unit circle. We are going to be talking about doing the unit circle backwards, and there are some restrictions that we're going to do, okay? Okay, so a couple of things that I really hope that you are taking away from section 10.3 as far as the unit circle is concerned, and this does go for the inverse trig as well. But there are a couple of things that I'm really hoping that you have been practicing, okay? So first of all, our exact values. So you're leaving things in terms of root 2 over 2. Obviously, you have to have your denominators rationalized, but you're leaving them as 1/2, no decimals, okay? The other thing that I'm hoping that you have gotten is an opportunity to practice those radians. This is going to help you tremendously when you are in calculus, okay? Pre-calc, calc, the whole, even what's coming up next for us, okay? Definitely radians. As a matter of fact, we're going to be talking about arc length in a minute or two, and arc length also uses radians, okay? The other thing that I hope that you're also taking away is that the sine of whatever angle is always the y value, the cosine of the angle is always the x value, and then tangent is always the y divided by the x, or sine over cosine, okay? So those are some things that I really hope that have been working out for you, okay? Just to kind of practice and reiterate really quickly, let's do the sine of 150, okay? So if I think about the sine of 150 degrees, I know that 150 is 30 away from 180, and sine is y, so that's a short side, okay? And so I know that the sine of 150 is going to be 1/2. The cosine of 4 pi over 3, and so if I think about my unit circle and I'm counting by 4 pi over 3, for some of you, you might be better counting by pi's over 6s, so that would be an 8 pi over 6. So 1, 2, there's 3, 4, 5, 6, 7, 8. And I want the cosine. And so since my 4 pi over 3 is all the way down here, that's going to be my short side of my triangle. And so the cosine of 4 pi over 3 would be a negative 1/2. So I'm hoping that that's going a little bit faster for you, okay? Let's talk about arc length really quickly. So the arc length will enable you to answer questions similar to this. Okay, so here is a word problem, an example for us. So we know that New York City is 45 degrees north of the equator. The estimated radius of the Earth is about 4,000 miles, and I want to know approximately how many miles a plane would travel to get from New York City to the equator. Okay, so first of all, when you're doing arc length, okay, you're looking at a circle, and arc length is going to be depending on what the radius is. So this is why we needed the radius of the Earth, but depending on what the radius is and what the opening of the angle is in between, you're going to be able to get this value right here. So the length of the circumference that is between, you know, that opening of that angle, okay? So here is a picture of what is actually happening with the plane in New York City, okay? So this is the Earth. It's a great picture, isn't it? Here's my radius. It's about 4,000. My degree is about 40 degrees. New York City is up here, and obviously here is the equator. So the formula that you need to know, because there is a formula, okay, is S equals R times theta. Okay, so this is the formula to give you this length on the circumference, or on, you know, the outside of the Earth, per se, in this one. Now, keep in mind, we're just estimating, so we're not talking about, like, the ozone layer and all that kind of other stuff. The thing about this formula, though, is that the angle should always be in radians. So in order for this formula to work, that angle has to be in radians, okay? All right, so let's go ahead and do this. So if I want to find this distance over here, right, I'm going to take my radius, which is 4,000 miles, and I'm going to multiply it by my opening, which is 40 degrees, but it's got to be in radians. So the other thing that section 10.3 is some practice at is being able to convert. So what is 40 degrees in radians, right? We have to go figure that out, okay? So we're going to do 40 times pi over 180, and this is what you had a little bit of practice with a couple of days ago, okay? If I do a little bit of dividing, I'm going to end up with pi over 4.5. I've already done that math, and so I know that that's what that is, but we're going to take that, that radian measure and we're going to substitute that in for the 40 instead, okay? So I'm going to get 4,000 times pi over 4.5, and that's going to give me the arc length, or how far the plane is going to have to fly, okay? So let's go do that math. So 4,000 times pi divided by 4.5 is this big old honkin' number, and if I round to the nearest mile, I'm going to get 2,793 miles. So that's approximately how far the plane is going to have to fly, okay? Okay, let's go talk about section 10.4. All right, so now we're going to talk about the inverse trig, and so basically we're going to be doing unit circle kind of backwards. So instead of me asking you specifically what is the y value at 150 degrees, what's the sine of 150, I'm going to say to you, okay, when is the sine 1/2? So what is this angle, okay? Instead of me saying to you, hey, go find 4 pi over 3 and tell me what the cosine is, or the x value, I'm going to say to you, hey, the cosine of what is negative 1/2? Now the first thing that you need to kind of realize is that these can be written in different ways, okay? So it could say the sine of what, right? The sine of x is equal to 1/2, okay? It could say the inverse sine. Remember, this little -1 does not mean to the negative first power. It's used in functions. I don't know if you remember doing f of x type of stuff, but back then, remember this f with the -1 meant the inverse, okay? So this is the inverse of sine, and you're finding when, that's going to be 1/2. The other thing that it could say is it could say the arc sine, okay? So the arc sine of 1/2. They all mean the same thing. Your answer is going to be an angle, okay? So whatever it happens to be that they're asking you for, your angle is, your answer, is the actual angle, okay? Let's talk about this, though, the sine being 1/2, okay? And this idea of restrictions is going to kind of start to come about, okay? So what I want to do, I actually want to look at my unit circle, but before I do that, I want to know when is the sine √3 over 2, okay? So the inverse sine of √3 over 2, when does that happen, okay? So on my unit circle, I've actually highlighted √3 over 2 on here twice because this is the problem. It happens twice, okay? If you look at your unit circle, √3 over 2 in the y position is over here as well as over here, okay? So this actually has two answers, okay? So the sine of, or the inverse sine, √3 over 2 is either going to be pi over 3 or 2 pi over 3, okay? So one of your answers, right, is pi over 3. The other answer is 2 pi over 3. But you know what? That still isn't it, because there are a gazillion answers. There's a gazillion things. Let's just talk angles in degrees really quickly, okay? If I'm looking at 60 degrees, I'm looking at one of my answers being pi over 3. Well, I can add 360 to that, and I get 420. I can add another 360 to that and get 780. I can even take my 60 degrees and I can go backwards and I can subtract 360 degrees. I could be here all day long. And then the fact that you can do that with 120 degrees, you can keep adding 360, adding 360, adding 360, subtracting 360, subtracting 360. You just wanted to see me go crazy, right? So here's what we do. Because we really want our focus to be in radians, okay? We really want our focus to be in radians. We're going to take our pi over 3 and we're going to add 360 degrees. But we're going to add 2 pi, okay? Because again, I want my focus to be in radians. I also want to be able to subtract 2 pi, but I want to be able to add or subtract as many times of 2 pi as I want, okay? And so we end up saying that one of our answers is pi over 3 plus 2 pi n, where n is an integer. Okay, so this is kind of like our reference angle, and this 2 pi n is taking care of the gazillion different times that you can add and subtract 360 degrees. The other possibility is also going to be over here at 2 pi over 3, okay? And so this answer is also, so one of your answers is going to be pi over 3 plus 2 pi n, okay? Add and subtract a million of them. Or it's going to be 2 pi over 3 plus 2 pi n, where again, you're adding or subtracting a gazillion of them, okay? Let's go try one more like that, okay? So when is the cosine negative 1/2? Okay? When is the cosine negative 1/2? So if I look at when my x value is negative, it's the short side, okay? The short side. I'm going to be up here, and I'm going to be down here. I know this is a little bit challenging to see. I'm so sorry. And so we're at 2 pi over 3 and 4 pi over 3. So we're going to say that this answer is 2 pi over 3 plus 2 pi n, or it's 4 pi over 3 plus 2 pi n, where n is an integer. Okay, so you have to add that in there to get the gazillion times that you can add and subtract 360 degrees. Okay? Okay, so all of that is going to lead us to this idea of having restrictions, okay? And so just taking a look at the unit circle, when we're looking for the inverse sign, okay? Remember, sign is the y value, okay? And so what we're going to do is we're going to stay in the positive x-axis, and we're only going to look at when and what angles are from here to here. So in quadrant number 1 and quadrant number 4. So the inverse sign, if you want to be able to just give one answer and not a gazillion answers, right? Because we could be here all stinking day, okay? You restrict it to negative pi over 2 and pi over 2. You're just restricting those angles in those two quadrants, okay? The cosine, because the cosine is the x value, we're going to leave our y value positive. And so you're looking at quadrants 1 and quadrants 2. And so if I wanted to know what the inverse cosine, what angles we're looking at, I'm going to restrict it from 0 to pi. Okay, so those angles get restricted from 0 to pi. Okay, now the tangent is going to be negative. Oh, I'm sorry, the tangent is going to be either positive or negative, depending on what quadrants that you're actually in, but sometimes it's positive, sometimes it's negative. And so we just kind of go back and we follow the same thing with the sign. Okay, and so we're looking at from negative pi over 2 to pi over 2. Now, I want to see with your challenge if you can figure out why I did not put lines underneath those, okay? All right, so I pulled up page 717 because part of your assignment is on page 717, but I just wanted to show you when you do these questions like 2, 3, and 4, and it says to find all the possible values, this is when you're adding and subtracting 360 from here to the end of time. When you're doing questions like this, where it says to evaluate them, this is when you're doing the restricted values, okay? Sometimes, like questions 12 through 15, they give you a specific restriction. These you're going to have to type into your calculator. Your assignment is to try these 2 pages. I'll be available if you need help.